You're welcome to Madhouse TV Mathematics class. Today we are going to look at using determinant to solve simultaneous linear equations. Two or more equations that the values of the unknown will satisfy all the equations. We say that the values of the unknowns are the letters in the equation. Let's say, for example, we have equation like this. X plus 2y is equal to 8. X plus 2y equal to 8. Then we have x minus y is equal to 2. Now let's say that this is a simultaneous equation. This is a simultaneous equation. The unknown values here is x and y. We are saying that for a simultaneous equation, the value of y and x, when they are placed in these equations, it will satisfy the equation. It will be correct when used. In this particular equation, for example here, the value of x, our x here is equal to 4. The value of x has been determined to be equal to 4, and that of y has been determined to be equal to 2. Now, we want to illustrate what a simultaneous equation simply means. It means that if we put 4 and 2 in this equation here, it will be equal to 8. And if we also put 4 for x and 2 for y in this equation here, it will be equal to 2. That is the meaning of a simultaneous equation. Now let's look at that. Let's check that and see. Check. We have what? X plus 2y equal to 8. So put the value of 4 for x. We now have what? 4 plus, and put the value of 2 for y. We now have 2 times 2. So what do we have? This is now what? 4 plus what? 2 times 2 is 4. And this is equal to 8. So it means the value of 4 and 2 satisfy the equations when substituted for x and y. If you do the same thing for the other equation, we are still going to arrive at 2. Now let's look at the other equation there. X minus y is equal to 2. So let's put the value. X is equal to 4 and y is equal to 2. So 4 minus 2 gives you what? 2. So it means the values of x and y, they satisfy all the equation. That is the meaning of a simultaneous equation. Now, going further into the topic now, we want to look at how do we use determinant to solve and get the values of x and y. In this example I use for illustration now, the value of x and y have been given to you. We are only checking. But now, when you are given the equation and you are asked to determine the solution means to find the value of x and y. Let's take an example. We are going to take an example of an equation. Let's say 5. We are going to have what? 5x plus what? 4y. 5x plus 4y equal to what? 3. And we now also have what? 3x minus 3y. Let's say equal to what? Minus 9. Let's say this is a simultaneous equation given to us. And we want to use determinants in solving it. Now, how do we use determinant in solving to find the value of x and the value of y? We are going to use the coefficient of x and y in each of the equations to form what? A matrix. To form a matrix. And we find the determinant of that. We are going to do that. Now we are going to look for that. Let's take this as the determinant for the matrix that will be formed. And what do we have? 5 3, and we have what? 4 and minus 3. We are going to look for the determinant of this value. What have we done? We are using the coefficients of x and y to form what? A matrix, which we are now looking for the determinant of this matrix. 5, 3, this is the x column, and 4 minus 3, this is the y column. So let's look for the determinant. How do we look for the determinant? We still remember, we now have what? 5 times minus 3, that will give us what? Minus 15. Then minus 3 times 4, that will give us what? 12. So what's our determinant? Our determinant will now be equal to what? Minus 15 minus 12. Minus 15 minus 12 will give us what? Minus 27. So this becomes what? The determinant for this. Now, how do we determine the values of x and y? We are going to look for the determinant of x. Determinant x. In looking for the determinant of x, now let's go back to this. Look at this. This is our x column. To look for the determinant of x, we are going to replace these coefficients here with the values of our constant in the new determinant. So what's the value of our constant there? We have 3 minus 9, 4 minus 3. So we have used what? The value of our constants in the equation to replace the values, the column of x in this determinant. So let's find the determinant of x there now. In finding the determinant of x, what do we have? 3 times minus 3 will give us what? Minus 9. So we now have minus, what do we have? Minus 9 times 4 will give us minus 36. So this becomes what? Minus 36. So this is minus 9. Minus times minus 36 becomes what? Plus 36. Becomes plus 36. So minus 9 plus 36 will give us what? 6 minus 9 cannot add 1, that becomes what? 16. Into 16, that will give us what? 7. And what do we have here? 2. So we now have what? 27. So we have 27. Now let's look at that. Let's look at that. How do we find the value of our x now? To find the value of our x, we now say therefore x is equal to x determinant divided by what? The determinant of the matrix. So what's our x determinant? Our x determinant is equal to 27. And the determinant of our matrix, what do we have? When calculated, is minus 27. So the value of our x is equal to what? Minus 1. When we subtract, it gives us what? Minus 1. Now we are going to look for the determinant of y. Now how do we look for the determinant of y? Just what we have done similar in our x1. Look at our value here. For our x column is what? 5 and 3. And the column of y now, we will now replace it with the constant, which is 3 and minus 9. We replace it with the constant. So what do we have? This will give us what? Minus 9 times 5 will give us what? Minus 45. Minus, what do we have? 3 times 3 will give us what? 9. And that will give us what? 9. So, minus 45 minus 9. That will give us what? Minus 54. So that becomes the determinant of what? Y. So to get the value of y now, y becomes what? Therefore, y is equal to what? The determinant of y divided by what? Our general what? Determinant. What is the determinant of our y? minus 54 all over what our general determinant is minus what? 27. So let's divide that. Minus divide becomes plus. 54 divided by 27 give us what? 2. So our y is equal to 2. So it means our solution is what? What's our value of our x? Our x is minus 1 and our y is what? 2. In writing our solution in this way, it normally follows our alphabetic order. The x comes first before the value of what? Y. Now, when you finish solving most times, it is good at times to cross-check and see if actually what you have done is correct. Check that by substituting these values into the equations and see if it fits. Let's look at that. Check. Let's check. Taking one of the equations. Let's take one of the equations. 5x plus what? 4y is equal to what? 3. Now let's see. Substitute for x there using what? Minus 1. So 5 bracket minus 1 plus what? 4 open bracket 2. And let's see if we are going to get that. 5 times minus 1 gives us what? Minus 5. Plus what? 4 times 2 gives us what? 8. And equal to what? 3. Minus 5 plus 8 is equal to 3. So it means what we have solved is what? Correct.